If you're building any kind of AI application, you have a huge decision to make, way before you even think about writing code. And that is, are you going to go with Retrieval Augmented Generation, or are you going to go with fine-tuning? This isn't just a technical detail. It has massive financial and performance consequences down the line. And when I say massive, I mean it. This can easily be a $10,000 decision. The amount of money you need up front for one of these paths can literally eat up your entire project budget right from the get-go.
Now, here's where a lot of teams go wrong. They look at this as just a technical choice, but that is a huge mistake. This isn't about tech. It's a math problem. And if you get the math wrong, you could bankrupt your project with costs you never saw coming, or even worse, end up with critical failures like the model just making things up. So, to really get a handle on the math, we first need to understand how these two things actually work. Think of it like this. One approach is like handing your AI a library card. It can go look up anything it needs. The other is more like sending that AI to graduate school to get a PhD. So let's break down the numbers and the performance for both of these.
Okay, first things first, we have to nail down the core difference in how these systems think. And they are fundamentally different. One is all about accessing knowledge from the outside, while the other is about teaching the model a new behavior from the inside.
So let's start with RAG. You can think of RAG as an open book exam. The model gets access to a bunch of external documents. When you ask it a question, it just looks up the relevant info and uses that to form an answer. It's all happening in its short-term memory, what we call the context window. Fine-tuning, on the other hand, is that medical school approach we talked about. You're not just giving it a textbook to read. No, you are fundamentally changing the model's brain, altering its internal neural weights to teach it completely new skills and patterns. This is all about its long-term memory.
And that right there leads us to the key mechanical difference. For RAG, the source of truth is always outside the model, in some document that it fetches in real time. But for a fine-tuned model, the source of truth is inside. It's baked into its own weights. And believe me, this one single difference is what drives every single trade-off in cost and performance that we're about to cover.
All right, let's talk money. Let's get into the economics of this, because this is where most teams really trip up. The cost structures for RAG and fine-tuning are basically mirror images of each other. We really need to look at CapEx, the upfront cost, versus OpEx, the ongoing operational cost.
So this table here lays out the full financial picture for each approach. We're going to focus in on the two most important parts, what it costs to get started and what it costs to keep it running. Fine-tuning is definitely a CapEx-heavy move. The upfront cost to prepare your data and pay for all that GPU time is pretty steep. We're talking anywhere from $2,000 to over $10,000 easy. RAG, on the other hand, is the complete opposite. It has a super low barrier to entry. You can get a vector database and your embedding logic set up for probably less than $500.
But, and this is a huge but, the operational costs are flipped. With RAG, you are paying for every single token you retrieve on every single query. At scale, those costs can become unpredictable and just explode. You might be looking at around 3 cents a query. A fine-tuned model, though, it's already learned the information, so your prompts are shorter and your cost per query is way lower and much more predictable, often just a tiny fraction of a cent.
So this all leads to a critical break-even point. The math here is actually really simple. If you're running an application with massive traffic, and we're defining that as over 1 million queries a day, the money you save on tokens with fine-tuning will absolutely make it the cheaper option in the long run, even with that big initial investment. Okay, so cost is just one piece of the puzzle. Now we need to talk about performance. We're going to look at both of these architectures across 3 really important metrics: speed, how up-to-date the information is, and how much control you have over its behavior. When it comes to speed or latency, fine-tuning is the hands-down winner. No contest. Because all the knowledge is already baked into the model, it just spits out the answer directly, usually in about 200 to 400 milliseconds. RAG is just naturally slower. It has to do 2 things. First, go find the data, and then generate the response. That 2-step process adds a lot of latency, pushing your response times up to almost 1.5 seconds sometimes. But when we're talking about data freshness and factual accuracy, RAG is the undisputed champion. It's not even close. If your information changes, you just update your external documents, and boom, the model has access to it instantly. A fine-tuned model is completely static. It's frozen in time from the day it was trained. It has no way of knowing about new data unless you go through that whole expensive and time-consuming retraining process all over again. Now, what if you need to control the style and behavior of the AI?
Well, here, fine-tuning is way better. If you need your AI to talk like a pirate, or write code in a very specific way, or always output perfect JSON, only fine-tuning can reliably bake those behaviors in. Sure, you can try to prompt a RAG system to do it, but it's going to struggle to stay in character consistently.
All right, so we've looked at the core concepts, we've run the numbers, and we've compared the performance. Now let's pull all of this together into a simple, clear decision matrix you can actually use. So, the final verdict really comes down to your specific use case. If you need to access information that changes all the time, like yesterday's news, or you need to query a huge private document, you want RAG. That's the right call. But if you need to teach the model a specific behavior, like how to talk like a doctor, fine-tuning is your only real option. And finally, if your main goal is just to get that API build down at a massive scale, the long-term efficiency of fine-tuning is the smartest financial move.
Finally, there's a little industry secret for projects that have the budget and complexity to handle it. You don't have to choose. You can use a hybrid approach. Here's how it works. You fine-tune a model to get the skills you want, the behavior, the format, the style. Then you use RAG to feed that specialized model with real-time facts. This way, you get the best of both worlds, perfect style and total accuracy.
So there you have it. You now have the complete framework to solve the RAG versus fine-tuning equation for your project. But solving one problem just leads to the next big question, right? And that is, where do you actually run all this infrastructure? Because the choice between the cloud, the edge, or running on device, well, that comes with a whole new set of mathematical trade-offs to consider.